morning friends. Today I am going to discuss a very important topic students. The topic name is one dimensional heat flow equation. What students? One dimensional heat flow equation. Let us see the concept students. One dimensional heat flow equation. Let OA be a homogeneous bar of uniform cross section of length small l. What students? Given OA be homogeneous bar students. Say take a homogeneous bar students. Homogeneous bar. What is it students? OA. So initial point is O and the end point is A. What is length students? Length is L. So length is L students. Length is L. Whose position is along positive x-axis. What students? It is a positive x-axis students. Positive x-axis. It is along the positive x-axis only. With x is equal to 0. What students? Here x is equal to 0. Here x is equal to 0 as n O and x is equal to L as n A. Here x is equal to L students. X is equal to L. The sides of bar insulated to prevent the loss of heat. What students? What students? The sides are insulated students. Insulated to prevent the loss of heat students. The loss of heat. Then the one dimensional heat flow equation is, what students? One dimensional heat flow equation is dou u by dou t, that is equal to c square into dou square u by dou x square. Once again students, dou u by dou t, that is equal to c square into dou square u by dou x square. So we can easily remember this formula students, because already we know one dimensional wave equation students. What is one dimensional wave equation? Dou square u by or y by dou t square, that is equal to c square into dou square y by dou x square. Okay students, what is one dimensional wave equation students? Dou square y by dou t square, that is equal to c square into dou square y by dou x square. See students, there we have dou square y by dou t square. In that place we have in one dimensional dou u by dou t. We can easily remember students, that's why I told you. Okay, dou u by dou t, that is equal to c square into dou square u by dou x square. Now what is u here students? U is temperature. What students? U is a temperature. U is temperature. T is time students. X is x-axis. Now where c square students, c square is equal to k by rho s. K by rho s. K is a thermal conductivity. Rho is density, everybody known. S is specific heat. What students? S is specific heat students. Specific heat. Okay. Now I want to find the solution of this one dimensional heat equation. Okay students, I want to find the solution of this equation students, one dimensional heat flow equation. So see students, here depending on the physical condition of the problem, we choose an appropriate form solution. Okay students, that means here what he says, physical condition students. That means the nature of the problem. Depending on the nature of the problem, we choose a appropriate solution students. We choose a suitable solution. Or students, we choose a suitable solution. Right. How we choose? Let us see students. Here as we are dealing with heat conduction problem. Okay students. Here we are dealing with heat conduction problem students. So heat conduction means here, suppose here at x is equal to 0, suppose I maintain at 0 degree centigrade students. At A I maintain at 100 degree centigrade students. Okay, at x is equal to 0 I maintain 0 degree centigrade and at O 100 degree centigrade students. Now I will give heat at A students. I will give heat at A. After some time, what happens, students? Suppose there is a particle, students, like this here. So this particle absorb the heat, students. If I continuously give to the heat to this bar, every particle receives the heat, students, maximum heat. After certain time, every particle receives maximum heat, students, maximum heat. Okay, now I will stop. That means the state is called steady state, students. Steady state. That means every particle receives maximum heat, students. That state is called steady state. After reaching the steady state, okay, students, after reaching the steady state, I will stop to give the temperature or heat. Okay, students, after reaching the steady state, I will stop to giving the heat, students. Or initially it is 0 degree centigrade, it is 100 degree centigrade. I can reduce 80 degree centigrade. Here I can increase 20 degree centigrade. Okay, students, I can change the temperatures or heat at the ends, or I can stop there. What happens, students, there? What happens when time increases? What happens in the bar, students? At the particle, the temperature is decreasing, students. The temperature is decreasing. That state is called transient solution. Transient state. So see here, students, it must be transient solution, that is U decrease with the increase of time t. U decrease, increase of time t. Okay, students, after reaching the steady state, if I stop, okay, what happens, students? What happens? The temperature is gradually decreased, students, with respect to time. So hence the appropriate solution, students. So appropriate solution is u of x comma t, that is equal to c1 cos px plus c2 sin px into e power minus p square c square t, students. Okay, students, e power minus p square c square t. Now see here, students, why it is appropriate solution. Here I have negative, students. Now whenever a time increases, here we have time, students. Whenever time increases, what is the value? What happens to this value, students? Time increases. If I increase here 1 hour, 2 hours, 3 hours, like this value will become reduced, students, decrease, students. So this value decrease means temperature is decreased, students. So this is a suitable solution for one-dimensional heat flow equation. There are two another solutions, students, like this. These are two another solutions. See here, students, I have c square p square t. When time increases, temperature also, students, increases. Here also same, students, x. When time increases, temperature also, here it is independent of time, students. Right? So what is suitable solution, students? Whenever time increases, the temperature decreases, students. That is a suitable solution. So this is the suitable solution. Now these two are not suitable solution. These two are not suitable solutions. So okay, after getting the solution, so here we find, students, which values, students? Come on, tell me. Exactly, we are finding C1, C2 value, students. How can you find C1, C2 value, students? Okay, students, we need here boundary condition students. Boundary condition, we know the length students, the length. So C students here, u of, it is function of u is function of C students, x and t students, x and t. What is x students? 0. Say t. What is another end students? What is another end? L. X is L at any time t. These two are boundary condition students. Say if I am right here 0 degree centigrade, it is 0. It is 100 degree centigrade. It is 100 degree centigrade. U of L comma t. These are the boundary condition students. Now I need initial temperature students. Okay students, initial temperature. Initial temperature means students u of x. Initial temperature students. That means T is equal to 0. T is equal to 0. So I need these three students. Say this is 1, 2, 3. Okay students, if I know these three conditions. Okay students, once again, what are the conditions students? Initial temperature, that is denoted by u of 0 comma t. So the length is L, so I can write u of L comma t. Suppose L is say 10 students, 10. So what is condition here students? U of 10 comma t students, u of 10 comma t. If it is 20, u of 20 comma t. If it is 50, u of 50 comma t. Okay students, we get the temperature, another temperature. We must know these two condition students. And also another condition is u of x comma 0. U of x comma 0 is initial temperature. Initial temperature. If we know these three conditions, we are applying here, then we get C1, C2 values students. C1, C2 values. That means at any time t, at the point P, we get the temperature students. We get the temperature U. Okay students, further in problem, how can we write the conditions and initial temperature? You will see in the next class students. Please like this video and share students as many as possible. Hope you understand. Thank you for watching this video. Jai Hind.